I'm talking about, can you guys? Okay. I'm talking about declarative programming. For me, when I first started writing declarative code, I've been writing code like forever and ever and ever. Basically, there really were like dinosaurs roaming the earth when I first started writing code. So I learned kind of like bad old ways. When I first started writing declarative code, it sort of like reminded me of magic. So that's the theme of this talk, whether you like it or not. So Feather Knee is my real name. I'm from New Mexico. And actually, everybody in the town I grew up in has a weird name. It's just a thing. I'm Feather Art on Twitter if you're interested in following me. I work at Nvidia, and I'm working on a platform for AI. And we are hiring, too. So yeah, and it's pretty exciting what we're doing. So feel free to talk to me about that. So declarative and imperative are both programming paradigms. And I put this duck up there because this doesn't actually really look like a duck, but you all recognize it right away as a duck. And so paradigm is a word that came before programming was ever a thing. It's actually from the 15th century. So it's just kind of a typical example of something, or it's a model of something. And so you can look at that duck and recognize right away, oh, that's a duck, even though there's not a lot of detail. So a programming paradigm is a pattern for organizing code. And it's either by state or by execution model. Some languages are sort of like built around a paradigm, like Elixir. Have any of you heard of Elixir? So Elixir is a very functional programming language. It kind of enforces that paradigm. Here's some other paradigms and even a pair of dimes. There's imperative, functional, declarative. These are all kind of different ways of organizing code. JavaScript is kind of built around which one of these paradigms? What do you guys think? All of the above? All right. You win the prize. The prize is no prize, but so yeah, JavaScript is kind of flexible. It has all these kind of practical foundations. When I first started using JavaScript, like back when I was like running away from a Triceratops, and I actually it felt like using duct tape. Like it was like Perl. It reminded me more of Perl. And now you can actually write this like very functional, clean JavaScript. And you can actually do that, all those different types of paradigms in one code base, which is like a beautiful thing and a terrible thing. So what's the best way? It depends. So, sometimes you have different goals. You might be trying to write code that is really optimized to run quickly. You might be working in a constrained memory environment. You might be just trying to write code that's really readable and easy to test. In most cases, in a front-end environment, you're trying to write the third kind. So React is a declarative kind of coding library, but it wasn't really the first one to have that idea. That idea has kind of been around for a while. I was doing Ember before this. Ember is also very declarative. Is that flickering up there too? Weird. Okay. I guess this chord is a little bit fidgety. So, like I said, declarative code kind of reminds me of magic. So you're going to see a lot of Harry Potter references in here. I hope you're okay with that. If you're not, well, too bad. Imperative code is, it gives you more explicit control over the flow. And you're also directly modifying program state. So if you look at a code example, this is a kind of an imperative way to summon an array. So you're using a for loop. You're talking about each individual element in the array. You're adding it. It's very descriptive. You could also be doing this using reduce. How many of you are familiar with reduce array method? All right, that's awesome. So this is a much more kind of like concise way of doing this. You can, how many of you are familiar with kind of like ES6, implicit return, a little bit? So usually in a function, you would have a return sort of written out with ES6, you get the ability, if everything's on one line, it's just implicit return, so you don't even have to write the word return. You don't even have to write any kind of extra semicolons or whatever. But I put semicolons in my code just because. This doesn't mean that all the best code is always on one line. There's kind of a line between elegant code and clever code. You run across this if you've worked with one of those people who just feels like they have to get everything on one line at all costs, and they just write stuff that nobody else can read. The best way between the imperative example and the declarative example is they basically have the same runtime, right? But one is a little bit easier to read. So you might be wondering, how do I know that they have approximately the same runtime? I told you guys there would be wizards. Didn't say which kind. So how many of you have heard of big O analysis? All right, so some of you. So if you haven't heard about it, it's totally fine. I've met a lot of engineers who've been writing code for years, have never heard of it. But it's basically kind of a really loose way of analyzing the runtime of your code. It has nothing to do with tires, but I just thought that was funny. So basically, if you iterate through an array of n elements, you'll have approximately what they say O to the n runtime. And if you look at a graph of that, that means that as your array gets larger, the runtime of your algorithm will increase pretty much like linearly. If you have two nested loops, then what's that? Anybody want to guess? Quadratic, maybe? Yeah. Okay, so yeah, you could see O to the n squared. That kind of starts to ramp up really quickly. So if you've ever kind of like gone through your code base and been looking for bottlenecks, like if you see like a double loop, that's usually kind of a sign. So this gives me kind of like a random sort of idea of how well my code is executing, even if I'm using these like array methods that are built into JavaScript, like reduce. So if you're writing declarative code, if you've kind of come from like an imperative background and you're sort of like you're used to looking at all of how your code runs, and declarative code sometimes can be a little bit less efficient. But in the case where you're trying to write code that's readable and testable, you can just leave that yak kind of hairy. Like don't shave the yak. But you still want to keep your eye out for things like triple loops, double loops. I just bring this up because when I first started writing a lot of declarative code, I didn't really know how to think about the big O or kind of analyze the performance of my code as much. This is an example actually where the imperative way is really fast. So if I'm going to unique an array using the imperative style with a for loop, I would go through this array and look for each element that was duplicated in the array. So I have like this running through an array, iterating through an array, and then looking up. Or I could use a set. How many of you have used sets a little bit? Cool. So you know a set, basically underneath a set, there's a hash, and that gives you constant lookup time. And a set only accepts unique elements. So this is a really fast way to unique an array. And it's very declarative and very clean. So you can see that it's actually, in this case, it's much more speedy than the imperative way. And we know that because we're nerds and we looked at the documentation, the TC39, how they implement the set. So there's three array methods that you get to know pretty well if you're doing a lot of declarative code. Filter, map, reduce. So which one of these became another array method? What do you guys think? That's right, smoosh. So we've talked about reduce. Now let's look at an example of filter and map. So suppose that you've been given the very important task of being the sorting hat for the day. I did warn you guys. So you're given an array of wizard objects, and each one has the wizard name and their house. You could use a for loop and just loop through and look at what their house is and push that into an array. Or you could use the filter that's built into JavaScript. And this kind of takes your code down to a really nice, clean one line. So let's look at map now. How many of you have actually seen this? Yes, right? I've watched it over and over again. Every time I'm like dying. Anyway, suppose you just get really excited for no apparent reason, and you feel like you want to express this excitement with an array of wizard houses with 3 exclamation points. It's a very specific need, okay? So you could do this using a map, using a for loop to map that on, and use string interpolation, which is kind of classic old school JavaScript style. Or you could use a map and a template string. And this is just, again, you're kind of doing the same thing, pretty much same runtime, but it's just cleaner. So if you do a lot of React, map will be in your code a lot. These are my actual dogs, by the way. They really are like best friends. So this is like kind of a thing that you'll do a lot. And as Ben kind of demonstrated, you can do a lot of this kind of logic outside of your render method. But and if I didn't want to kind of like take it apart. Everything is together here. But you can see that here you're taking that same exact array of wizard objects and you're mapping JSX elements onto them. And JSX, it's just JavaScript, right? So we had that talk already. So how many of you have done jQuery before? You have, right? So basically most of us. So this is very different from jQuery because in jQuery you're kind of like directly manipulating the DOM. It's very hands-on. With React, you're never touching the DOM. All you're doing is setting state. So this is actually a really key difference. Remember, we talked about a paradigm as kind of either by execution model or by state. So what is state? So it's just the current value of any of the variables. So if you're logged into your bank, the current user is going to be your name. And this is kind of an example of just direct manipulation of the DOM to reflect changes in state. How many of you remember like append to, append to, append to? So much appending. So with the declarative UI, this is so much cleaner. It just, like for me, this really did feel like magic kind of when I first started using JSX and just setting state. It's so clean. So in summary, declarative code describes what, but not how, basically. You don't necessarily touch the DOM. You're kind of hands-off on the DOM. And your goal is mostly readability above other things like yak shaving. If you have any questions, feel free to come find me on the break. And I also can be found on Twitter at FeatherArt. And I wrote a Medium story with all the code bits in here in a GitHub repo. So there's that. All right, thanks everybody.